to this point, we've been doing simple linear regression, which means that we only have one predictor that we're using to explain our response variable. Now we're going to start multiple regression, which just means that we have multiple predictors. And we're going to start with a special case where that second variable is an indicator variable. So it's a binary option. Here we're looking at lakefront houses and houses that are not on the lakefront. Okay, so let's think about whether it's important to account for location in this house prices example. So we can see the relationship, the graph on the left is the relationship between square footage and price, and it looks pretty nice, fairly linear. But if we color the points by lakefront and not lakefront, we can see that there's a pattern, right? And this is even more clear if we look at the residual plot there on the right, that the lakefront houses tend to have positive residuals, which means their prices were underestimated. And the not lakefront houses tend to have negative residuals, so those houses were overestimated. So it seems like it is important to account for location in this data. So let's look at our Chapter 4b notes. So notice that we have two x variables here, size of the house, which is what we were using before, and location. So location, I said, is going to be an indicator variable. Indicator variables have just two values, 1 and 0. So 0 is like the baseline group. So remember, when we're looking at output like this, this says location not lakefront. So that's telling us the one that's not mentioned is lakefront. So that's the baseline group. And then 1 would be not lakefront. So 0 is where you put the baseline group. This is probably not how I would have set it up if I were doing this by hand. I probably would have said not lakefront would be the baseline, but for now, just to keep it simple, I'm going to go with the R defaults, and this is how R sets it up. Okay, so let's write out our prediction equation. So our predicted values, our y hat, would be, our intercept is 261.04. plus 0.1481 times x1. Remember, that's the size of the house. By the way, I have changed this to where the prices are given in thousands, so that's why the scale of these slopes has changed now. Minus 331.22, and this is where we plug in our location variable. So what we're plugging in here would just be either a 0 or a 1. So before I tell you how to interpret these, I kind of want you to try it yourself. It's definitely worth kind of wrestling with this a little bit on your own to make sure that it really sticks with you. So first of all, think about how could you write a separate prediction equation for each level of the categorical variables. So basically, you're just plugging in the appropriate value for lakefront and not lakefront into that x2 variable. And then think about how would you interpret the intercept, the coefficient for square footage, and the coefficient for location. So remember, intercept, that's the predicted value when everything is 0. What does that mean in this context? And then slopes, that's usually telling you the predicted change in y for a 1 unit change in x. What does it mean to have a 1 unit change in x now that we have these new indicator variables? So go ahead, pause the video right there, pull out some scratch paper if you want to, and see if you can answer these questions. Okay, so let's start by writing out the equations for each of these groups. And I'm going to start with lakefront because that's the baseline group. So that one's going to be easier because if you think about just plugging in 0 here for x2, that part is just going to go away, right? So you're just going to be left with this slope and intercept. So for lakefront, what's given as the intercept and the slope, that's going to be the prediction equation for the lakefront houses. So basically this corresponds to the red line that's shown here. Okay, and then for not lakefront, we're going to be plugging in 1 for x2. So we've got the original equation, 481 times x1, but then when we plug in 1 here, we get negative 331.22. Obviously, you can write that as a times 1 if you want to. So basically, we have the same slope that goes with square footage, but now we have two constants that we're going to put together. So basically, once we put those together, that's going to become like our new intercept. So we end up with this adjusted intercept, negative 70.18, plus the slope, which stays the same. So in this model, this is actually an assumption that you're going to have the slope the same each time. Because of the way the model was written, it would always come out this way, but we have this adjustment to the intercept. Okay, so how do we interpret those coefficients? So why don't we start with the intercept? So if we want to interpret that first value, 261, that's going to be when you plug in 0 for all of the explanatory variables, right? So we would say 261.04 is the predicted price, and again, we're talking about predicted price in thousands, so it would really be like 261,000. The predicted price in thousands for a house with 0 square feet, so obviously that's conceptually problematic, with 0 square feet. And what does 0 indicate in terms of location? It means that it would be on the lakefront. So just like before, sometimes interpretations of the intercept make sense and sometimes they don't, but we just have to think now that 0 refers to a particular category. It's telling you that you're in that baseline category. Okay? So then what about B1? So this is the number that goes with square footage. It's going to be interpreted very similar to what we did before. So we would say as size increases by 1 square foot, the predicted price increases by, I'll go ahead and multiply it out this time, basically $148, right? And notice that this is referring to both groups, right? They both have the same slope, but we're looking at them separately. So because of how we're looking at the two groups separately, we have to add this extra tag here. Predicted price increases by 148 after controlling for the location. So I'm guessing when you wrote out your interpretations before, you probably didn't have that little tag, but that's actually really important. We always want to say that we're either controlling for the location, you might say adjusting for, or holding location constant. Those would all be tags to say that you're taking location into account. Okay, and then what about B2? So this was that adjustment to the intercept, right? Going from 261 to negative 70. You can think about it if you look at the picture as B2 is telling you how much you've shifted down from the red line, which was your baseline, to the blue line, right? So it's basically telling you the distance between these parallel lines. So we would say the difference in the predicted prices, right? The predicted price for a house that is not on the lakefront and it's negative, so we would say predicted price for a house that is not on the lakefront is 331. Remember, this is in thousands. Let's go ahead and convert to keep it simple. $331,224 lower than for a house that is on the lakefront. But again, we do need to have that tag because remember, we're talking about the distance between these lines at any particular x value, right? It's important that I drew this line straight up and down and that I'm not comparing a lakefront house of one size to a not lakefront house of a different size, right? So again, we need to add a tag that says something like holding the size of the house constant. So I used a different one here, but again, these are all the same. Controlling for, holding constant, adjusting for, those all mean the same thing. So this really builds on what we did with simple regression. I would say the main thing to remember is that you have to have this tag, that when you're talking about multiple regression, you're seeing the effect of one variable while controlling for or adjusting for all the other variables in the model. Later on, you'll do some practice with R, and you'll have an opportunity to practice these interpretations again too.